outdoor stream. Okay. Now, we look at question number 2. We read it first. A random sample of second-year business students at a small Canadian university were polled by a researcher attempting to establish a relationship between hours of study in the week immediately preceding a major exam and the mark received. So you're comparing hours of study before the exam to the percentage. Question A, is there a relationship between time spent studying and exam grade? Now, in order to answer this question, you need to do the correlation. And what is the correlation between them? And if there is, describe the relationship in your or work. Okay, anytime you see a question, you see correlation, the word correlation or regression, that means that it's a regression analysis. And in the regression analysis, there is X, there is Y. X is always the independent variable, and Y is always the dependent variable. And you need to know which of the two is X and which of the two is Y. The trick here is you always predict Y. So you look at the question, you read it carefully, you look for the word predict. You'll see it somewhere in the question. For example, in this one, in E, your mark, what mark do you predict A will get in the exam? So exam mark is what's being predicted. So this is exam percentage. And the X variable would be the other one, number of hours. Now, since they want you to find the correlation, if you go to your formula sheet, the regression section, correlation is R. Coefficient of correlation. And you'll see the formula for this is SSXY square root SSX times SSY. We don't have any of the SS's, we need to calculate them. In that same section, you'll see the formula for all these. SSX is the famous sum of x squared over n. And since we know that x is hours, so remember, you have hours, you have exam percentage for 10 different students, and the hours would be like 12, 25, 12, and numbers. Exam, 93, 57, and the rest. For the sum of x, since x hours, you add up the numbers here. And for the sum of x squared, you square each number individually, and then you add them all up. I did that. This one is 3832. This one is 188 squared and we divide by 10. 297.6. That's the answer for the first one. You also do the SSY, which is pretty much the same formula but for y. And since y is exam, you're going to add them all up. You're going to square each one of them and then add them all up. Again, I did that. This number is 65,143. And the number 73 squared over, and there are 10 students, 2258.1. You also do the sum of xy. Sum of xy, sum x, sum y over n. Now, sum of x, y means that you multiply x and y, you get a number. X and y, you get a number. X and y, you get a number. After you multiply each x by the y, you add them all up. That's your sum of x, y. Did it? 15,540. Sum of x is the 188. Sum of y is the 793. And there are 10 students. Your SSXY is 63.6. So we are ready to put everything in the correlation. SSXY is the 631.6. SSX is 297, and the SSY is the 2258.1. So you go you do this and it gives you 7705. That's your correlation. Now I'm going to erase some of this. But I'm going to just say SSX, and again that's hours, 297.6. SSY, that's exam percentage, and that's 2258.1. And SSXY 631.6. We got this R value. Now we need to talk about what does this mean? Is there a relationship? If your R is more than 0.8, then there is a strong relationship. If R between 0.6, 0.8, that's a good relationship. If R less than 0.6, you have weak, or if it's very, very small, no relationship. So this number is somehow like it's good, but it's very close to being strong. So you say the R value indicates a very good relationship between hours spent studying and exam percentage. The other thing that you also need to talk about is when you calculated R, was R positive or negative? In this case, positive. It could have been negative, but in this case it's positive. So you say, since R is positive, that means that number of weeks and exam percentage are positively related. Positively related means increase in number of hours lead to increase in exam percentage. So positive, that means that they go together. One increases, the other increases. One decreases, the other decreases. And negative relationship means one increases, the other decreases. So I'm going to add the R value, which is the coefficient of correlation. So all we did so far was the answer for part A. So we know now that there is a relationship. Can you find the regression line for predicting? So another time we see the word predicting, do this by hand. Now, I'll explain the idea quickly. You don't have to do this part. I'm only doing it to show you something. Because he could ask you in the final exam to do it. It's called the scattered diagram. You know X, you have Y, X is hours, and this would be exam percentage. The hours minimum is 8, maximum is 26, so I'll divide this into say 5, 10, 15, 20, 25. Percentage maximum is 95, minimum is 55, so I'll divide this in 20s. Now each student I'll indicate by a small x. So first one, 25 and 93. I'll say somewhere here. You have 12 and 57. You have 18 and 55. You have 26 and 95. 19 and 82. 20 and 95. 23, 95. 15, 80. 2285, 8 and 61. The idea is to see if we can find a straight line, the closest possible straight line to all points. This line that we're trying to find is called the equation of the regression line. So it's the regression line, sometimes call it least squared line, and it's the famous mx plus b, but for regression we say y equals b0 b1x, where this is the y-intercept and this one here is the slope. To actually calculate this, we start with calculating the slope first, and that's SSXY over SSX. SSXY we have, that's 631.6. SSX is the 297.6. So you divide them, and that gives you 2.1223. And then you find the intercept. That's average of y minus slope average of x. Average of y, we remember average, you add them all up, divide by the number. I added them up. Adding the y's together, the exam percentages together, they add to 793. You divide by 10 students to get the average. The slope, average x, you add the numbers for x. We did this earlier. Adding the numbers for x, they add to 188. You also divide by 10 students. So you go do this. So B0 is 39005. I'm going to add this to my summary here. B0 is 394005, and B1 is 2.1223. So after doing this, we are ready to put everything together in the formula. Y is exam percentage, intercept 39, slope 21223, and x hours. This is what they're looking for. So I'm going to add this to my summary here. So exam percentage Okay, now, again, don't do this unless you ask for. Another possibility, don't do it, is show the regression line you just did here. To show the regression line, we draw it by the standard way of drawing, where you put x and y and you just assume two numbers. I'll use 0 and I'll use 10. If I plug 0 into x, it gives me 39. And if I plug 10, it gives me 39.4005 plus 21,223. This gives me 60,6235. At 0, you're 39. At 10, you're 60 something. You connect. You extend. This is the straight line that's closest to all points. So we're able to do this. Now, in the exam also, not in the question, she will ask you to definitely to interpret the meaning of the y-intercept and the slope. So what does this number mean, 39.4005? And what does this number mean? B0 means that initially, when number of hours is 0, the exam percentage is 39. So if the student does a study, or basically when initially hours equals 0, then exam percentage is 39. So we consider this the start of life, because anything starts from 0. So when this is 0, the exam percentage is 39. Now what does the slope mean? Every hour you study, your exam percentage will go up by 2.1223. For every hour spent studying, exam percentage will go up by 2.1223. Good? Okay. Question C. Calculate the coefficient of determination and interpret what it means. We have the coefficient of correlation. Now we need the coefficient of determination, and that's R squared. Where you just take the R value and you square it. So 59, about very close to 60%. Now what you need to know about these two are, could be positive, could be negative, depending on whether you have a positive relationship or a negative relationship. But the number is between -1 and 1, so the value of the number never exceeds 1. And it's not a percentage, so you can't say it's 77%. So this number could be positive, could be negative, depending on the relationship. It's always between -1 and 1, not percentage. This number is always positive, and it is a percentage. The way you explain this, you say 59% of the variations in Y, which is exam percentage, can be explained by X number of hours in the regression line. So the interpretation of R squared is standard. Only the percentage change and what Y was and what X was, but everything else is the same. In one of the exam, she asked for what's the percentage of variations that cannot be explained. So in one of the exams they asked what percentage cannot be. We know R squared is the percentage that can be explained. Cannot be explained, you go 1 minus. And that gives you about 40% cannot be explained. Okay, I'm going to add this to my summary as well. Question D. Now in question D, is the sign of the slope logical? It's positive. Is it logical? And if the slope had an opposite sign, what would that tell you? Well, first of all, it is logical, since we know that the more the student studies, the higher exam percentage likely to get. So just explain why you think it's logical. It is logical because more hours, more exam percentage, and that's what logic is. The more you study, the higher you get. If the sign is negative, then it would mean the more you study, the less exam percentage to get. So if it was the opposite sign, it would mean that the more they study, the less exam percentage, which again doesn't make sense. So that's the answer for D. Now, what mark do you expect Arya will get on the exam if he spends 25 hours of study? So a lot of people, when they see this question of like how many hours of study, they go right away and they say, well, yeah, 25, plug it in and we'll know her exam percentage. Not exactly. You need to go back to the table. Is 25 hours within range of allowable hours? So like if you go to the table, the minimum number of hours you have 8, maximum is 26. So 25 is good. It's within. You can plug it in. But if they say, can you predict the mark for someone who studied 35 hours, you say no, outside range. 40 hours, no, outside range. 5 hours, outside range. So you can only use this equation to predict if you're within range. So you say exam percentage and you say 25. Her exam percentage would be 92,458. Good? Now, this is at for question 2, but it's likely to ask you a hypothesis question, like at 5%, is there a relation? Can we predict? So they start with giving you a certain percentage or significant level, and they'll ask their relationship, can you predict? So you start H0, HA. So for regression, whatever they say no, no relation, no, cannot predict, and this, yes, there is a relation. So we actually know that there is a relation. We already have that established. Now we need to prove it using hypothesis analysis. Test. Now, if you look at the formula sheet, in the middle column, you see there is a T-core equation, which is R minus this n minus 2. And there's also a T-slope equation, which is B1, capital B1, SB1. Well, in fact, it doesn't matter. They're both, it's a little bit different, but eventually both numbers, they'll give you the same thing. Here, we have everything, we have everything, we don't need to calculate. Here, you'll see that you're missing this, but there's a formula for it, so you can, there's extra work you need to do with this one in terms of calculations. I'm only gonna do this using this formula, but it doesn't matter. This is your rule. Since they say relationship in general, I'll do it two-tailed. If t test more or t less than negative, we're going to reject H0. Why I'm doing it two-tailed? Because the question was, is there a relationship? But if the question was, is there a positive relationship, I'll do it one-tailed. I'll do it t more, upper tail only. To get this number, we need degrees of freedom. Only for regression, it's n minus 2. 10 student minus 2, 8. And alpha is 5%, then divided by 2, because we're doing a two-tailed. So I'm going to go to my t-table. The number common between 8 degree freedom and 0.025 is 2.306. Calculations or analysis. We put everything in the T core. R was this number. This delta P, we call it raw, is always 0. So don't worry about it. This and this, always 0. One minus r squared and in the bottom n minus 2. Seven, 705, and in the bottom I have 1 minus 5937 over 8. This number is 3419. We are ready to make a conclusion. Your t-test, 3.419. Is that more than 2.306? Yes, definitely more than 2036. So the condition is satisfied. We're going to reject H0. Again, type 1 could be committed with risk equals alpha 5%. Rejecting H0. Yes, we have enough evidence to show that there is a relationship. And again, if you do it using this, remember there is extra work to do this, and actually there are a couple of formulas you need to do to get this. But eventually, when you calculate t-slope, it will be the same number, and the conclusion will be the same. So this question is good. It covers all aspects of the regression analysis you need to know, except for confidence interval. There are 3 confidence intervals in this section. There is one for slope, there is one for single, and there is one for hours. I might actually send you another video that I recorded for a different regression question that involves finding these, but in terms of the concept, it's pretty much the same concept, but it's like different formulas and a little bit of more work. But just to be on the safe side and know exactly everything you need to know about regression. So this is all for question number 2. If you go back to the assignment, question number 3, remember when I was talking about ANOVA? And I said, anytime we compare three groups or more, we use ANOVA. And I said there is single ANOVA, also called one-way, also called independent ANOVA. And there is double ANOVA, two-way, dependent. And for the one-way, for the independent, you ask yourself, do we have different groups? So the group doing the group or the sample in the first group, is it the same people in the second, same in the third, or different? If it's different, single. If it's the same group, it will be double ANOVA. So I want you to read question 3 carefully before we do this question. So, and after you read it, in my part 3 video, I'm actually going to go over this question, and I want you to tell me, is it single ANOVA or double ANOVA? So I'll see you in part 3.